Hello everybody, and today we'll be discussing the first topic in our course, namely permutations of distinct objects. We also come across the fundamental principle of counting, which states that if one event can occur in m ways and another event can occur in n ways, then both the events together can occur in m into n ways. So this is a tip that we need to remember, that when two events or more occur simultaneously together, we multiply. So we learn in this section what is a permutation. So by a permutation we mean an arrangement of objects, and we learn how to evaluate permutations and how to calculate permutations of distinct objects. So what we need to remember is that a permutation is an arrangement. Now, NPR is the number of ways of arranging n different objects taken r at a time. An NPR is given by the formula n factorial by n minus r factorial. So NPR is n into n minus 1 into n minus 2 up to n minus r plus 1. For example, 5p2 is 5 factorial by 5 minus 2, which is 3 factorial. So 5 factorial is 5 into 4 into 3 up to 1. 3 factorial is 3 into 2 into 1. So your answer is 20. 5p2, this is a hint to remember. When you are given 5p2, just go back from 5 2 times. So 5 into 4 is 20. 6p3 is go back 3 times starting from 6. 6 into 5 into 4, which is 120. Now NPR is also denoted by PNR. Coming to questions, find n if n plus 1 p3 equal to n p4. Now, n plus 1 p3 is n p4 is given to you. So what do we do with this? We go back 3 times. So n plus 1 into n minus 1. And here we count back up to 4 times. So I get n into n minus 1 into n minus 2 into n minus 3. So n into n minus 1 gets cancelled on both sides. I get n plus 1 equal to n minus 2 into n minus 3, which is n squared minus 5n plus 6. So simplifying and taking everything to one side, we get n squared minus 6n plus 5 equal to 0. So I have n minus 5 into n minus 1 equal to 0. So the possibilities are n equal to 1 or 5. Now n equal to 1 is not possible. Why is that? Because then I will have 2p3 or 2p4. It's not possible. So n equal to 5. Coming to question 2. In how many ways can 7 books be arranged on a shelf if there is no restriction, 3 particular books always stand together, 2 particular books must occupy the ends? Now, if there is no restriction, the 7 books can be distributed in 7 factorial ways. Why is that? Because the first book can be arranged in 7 ways, the second book can be distributed in 6 ways because one place is already taken up, the third book in 5 ways, and so on. Now, if 3 books are to stand together, this is a method we follow when something is together. Treat the 3 books as 1. There are now 7 minus 3 plus 1, that is 5 books left. And these can be arranged in 5 factorial ways. And the 3 books between themselves can be arranged in how many ways? 3 factorial ways. So by the fundamental principle of counting, the total number of ways is 5 factorial into 3 factorial, which is 720. Now, when the 2 books are fixed at the end, so fix the 2 particular books at the end. So how many books are remaining? 5. And these 5 books can be arranged in 5 factorial ways. And the 2 books between themselves can be arranged in 2 factorial or 2 ways. So again we use the fundamental principle of counting, and total number of ways is 5 factorial into 2, which is 240. Question 3. Find the number of all 5 digits with distinct digits. So there are 10 digits 0, 1, 2 up to 9. Now the first digit cannot be 0. Why is that? Otherwise it becomes a 4-digit number. So the first digit can be chosen in 9 ways. Now there are remaining 9 digits. From 0, 1, 2 up to 9, 1 has been taken up. And the second digit can also be chosen in 9 ways. Now there are 8 digits remaining. So the third digit can be chosen in 8 ways. Then the fourth digit can be chosen in 7 ways. The fifth digit can be chosen in 6 ways. So again, by the fundamental principle of counting, the total number of 5-digit numbers will be, we multiply the different ways. 9 into 9 into 8 into 7 into 6, which is 27,216. Coming to question 4. 4 different maths books, 6 different physics books, and 2 different chemistry books are to be arranged on a shelf. How many different arrangements are possible if the books in each particular subject must stand together? The maths books must stand together. So when something is together, we treat the maths books as one, the physics books as one, and the chemistry books as one. So there are how many books now? 3 books now. And these can be arranged in 3 factorial ways. Now how many ways can the 4 maths books be arranged in? 4 factorial ways. What about the 6 physics books? They can be arranged in 6 factorial ways. The 2 chemistry books in 2 factorial ways. So your total number will be 3 factorial, which is the 3 books, the into 4 factorial into 6 factorial into 2 factorial. That is 2,07,360 ways. So again, what do we use here? The fundamental principle of counting. Now going back to the second question, the maths books only must stand together. So what do? Treat the maths books as one. So these can be arranged in 4 factorial ways, the 4 maths books. And how many books are remaining? 6 physics and 2 chemistry plus 1, that is 9 books remaining. And how many ways can they be arranged? 9 factorial ways. So again, by the fundamental principle of counting, total number of ways is 9 factorial into 4 factorial, which is 87,09,120. Question 5. How many arrangements can be formed with the letters of the word vowels? If there is no restriction, each word begins with S and ends with E, and all the consonants come together. Now, can you note from here that no word is repeated? So all word letters are distinct. So the word vowel has 6 different letters. They are all distinct. And how many ways can they be arranged in? 6 factorial, which is 720 ways. So when there is no restriction, the 6 letters can be arranged in 6 factorial ways. Now, if S and E are fixed at the end, you fix S and E. So how many letters are remaining? 4 letters, which can be arranged in 4 factorial, that is 24 ways. And if the consonants are together, now what are the consonants? B, W, L, S, nothing is repeated, so treat them as 1. So how many are remaining? 6 totally, minus 4 plus 1, that is 3 letters, and they can be arranged in 3 factorial ways. So what do we use here again? The fundamental principle of counting, that is 3 factorial into 4 factorial, where 4 factorial is the number of ways the consonants are arranged. So we get 144. So we have learned what are permutations and how to evaluate them, and how to evaluate permutations of distinct objects using the fundamental principle of counting. If you are a class 11 student or a student appearing for the NATA mathematics exam, I strongly recommend you take a paper and pen and work along with me. So I have given some assignments, and after doing it you can check your answers as well. So thank you for watching course 1 and see you in course 2.